Hey, we have a lot of content today. I'm Dennis Streeter with DASI Solutions. Darren has gotten us kicked off here, and we have a number of guests coming into our presentation today as well. And what I'd like to do is run through a brief agenda of what we're going to be talking about here today and introduce those folks for you. So if we can move on to the next slide here. Real quickly, this is going to be a little bit different content than maybe what you're normally used to from us. We're not going to be talking a lot about SolidWorks, showing you a lot of features and functionality and cool stuff like that. And we're not going to be talking a lot of, if much, about any of our third-party solutions aside from a little bit on data management. Instead, we're going to be giving you what we consider to be a lot of the foundation for creating a good environment to run SolidWorks in. So we're going to be getting things kicked off, talking about how SolidWorks will access that data both locally and over a network. And then we'll get into a little bit of the heart and soul of the network environment itself. We're going to have a guest speaker coming in from SafetyNet. Kevin Bozung is going to be talking to us about network infrastructure and the server environment. And then we're going to have Eric Piper stepping up next and talking about the workstation environment and some technology that's going on with those today that you'll want to take into consideration. Both those gentlemen are going to give us some tips and tricks along the way for monitoring information and maybe fine-tuning some of your environment to get more out of what you have already today. And then also interjecting a lot of good comments along the way and kind of kicking off our initial conversation is going to be Matt Johnson from SolidWorks. And then Darren's going to wrap up the session along with Mark talking about some of these topics with data management and getting into a little more of the detail there on some of the key things that you might be encountering today that are related to your hardware performance. So with that, what I'd like to do is move on and introduce our guests to you here to get started. Mark Johnson, as I mentioned, from SolidWorks Corporation, is joining us today. Mark's been with SolidWorks now for just a little bit over 6 years, and he works solely in the technical support department. He's the guy that we go to when we have questions that we can't answer. So you see some of the things that he's achieved over the years here. And he also sets up the tests that we get graded by on our support desk. So a lot of information crossing Mark's desk, and he's going to have some great tips and tricks for us. And as I said, kind of lay that foundation initially on data access. Our next speaker that we have is going to be Kevin Bozung, and Kevin's principal over at SafetyNet, who we've done some work with over the years, and their group works exclusively in the networking environment. So he'll be sharing his wealth of experience in that regard with the network infrastructure items that are critical to running a good environment, good sound foundation for smooth data transfer, and he'll give us a lot of tips on the network server environment as well. So you can see some of Kevin's credentials here as well. And as we move over to Eric Piper from HP, I'll also note that all of our contact information is going to be given to everybody at the end of the presentation, so that if you have any questions that you'd like to ask, feel free to grab those. Or as Darren said, we're archiving this. You can also request a copy of the presentation, and I'll get that out for you. And then last of all, something new that we're doing as well is you might have noticed our blog site is kind of revived over the last few weeks. We're committing to put out regular articles on the site, and a couple of them already there relate to this webinar. So if you have questions that we don't get to today, please feel free to go and post those to our blog site, and that information will be at the end of the presentation as well. So last of all, we have Eric Piper coming to us as well today from HP, and Eric's a member of the Personal Systems group over there, working with a number of large organizations that utilize CAD, and he gets his hands dirty every day at the workstation level, helping them optimize their environment and making recommendations for maintaining their systems and what type of equipment they should be looking at based on the CAD design work that they're doing. So we're looking forward to seeing his presentation today and sharing his information as well. So with that, what I want to do is do a brief introduction right now for the next topic that we have coming up, the first topic, and that's the network environment. And the first thing that kind of lays the foundation for this topic is a discussion on how data is accessed. And we're going to turn the stage over to Mark Johnson of SolidWorks to talk about that, and then we'll go on to hardware considerations that Kevin will be talking about. And Kevin will also have some tips and tricks and information for you to learn about how to monitor your environments today, and maybe some tuning advice that he can share with you to maybe eke out a little better performance than what you're experiencing right now. So I'd like to turn the mic here over to Mark and let him start talking and getting our topic kicked off on the technical front here. Mark, thanks a lot for joining us. Appreciate you getting up here early.
No worries, appreciate it. The one thing on my slide there where you said that I am still technically a certified support technician, that's actually not correct anymore. Believe it or not, my certificate inside the system has expired. Although I do write the exam, though. I've written the exam for the past 5 years, so I'm not sure if I should. I'm not sure if it's fair for me to write the exam and me take my own exam. So just throwing it out there.
Well, anyway, you got the inside track there.
I got the inside track there. So all right, folks, we're going to look at a scenario that I'm sure some of you guys have seen. You know, when you have a large assembly or medium-sized assembly or any assembly which has got, you know, a number of part files, sub-assemblies and whatnot, even if it's structured properly and built well, it could be slow to load, you know, every time. And there's some other factors which could come up with regards to read-write flags and conversions and other things like that. But we're going to talk about just networking performance here today, okay? When you open the file from your local drive, you send SolidWorks sends the request to the CPU. It sends the command to the hard drives. Hard drives spin, or solid state drive, they don't spin. It sends the data through the south bridge, through the CPU, through the north bridge, RAM, and then it's loaded. It's loaded into RAM. That's how fast it happens. 7,200 RPM hard drives have about 50 to 60 megs per second read speed. 15,000 RPM hard drives or 10,000 RPM drives, you know, are around 160 megs per second. Some of the new solid-state drives out there, you know, for a couple $100, you can go out and you can buy a 125 megabyte solid-state drive, which will have over 220, 250 megabytes per second read speed. Well, let's take a step back here and let's look at what happens when you open it from a network. Okay, when you open it from a network, it sends the command to your Ethernet card. It sends the command out on the wires from the Ethernet card to your router, switch, hub, and bounces all around your server room and through the switches and whatnot till it hits your server. Once it finally hits the server, and even if it's a beast of a machine, now the server spins the hard drive, has to process the request. In addition to all the other requests it's getting from everything else that it's doing, it has to then transfer the data through the server south bridge, through the server CPUs, which means it has to reserve space in the processing queue against other processes like mail and anything else which you may or may not have in your server. Once it runs to the server CPU, it goes to the server Northbridge, server RAM. So on the local machine, that's already done, would have been already done if we were loading locally. But now, once it's done with all that, it's got to send it back the way it came. It's got to go out through the network and through the switches and hubs and routers and whatnot, into your Ethernet card, through your south bridge, through your CPU again, which is what do when you load locally, through the north bridge, RAM, and we finally loaded that file. You know, it all happens, you know, in a few seconds, you know, when at the speed of networks go. But network speed isn't exactly what a lot of people think it is. I'm going to kind of go out of order here. A network speed that we have today, which is most people have now, you know, gigabit networks. It's important to know that gigabit isn't gigabyte. People frequently, you know, it's a common mistake. Hey, I got 10 gigs of RAM in this machine or 12 gigs of RAM. So they hear gigabit network and they say, oh, I got a gig network. Well, you have a gigabyte network, which and there are 8 bits to a byte. So if we do the math out, that means you have a max theoretical speed of 125 megabytes. That doesn't mean that you and your neighbor and your neighbor and your neighbor all each get 125 megabytes. The total speed of your network max is 125 megs a second. So you will be lucky if you get that. So not only is it slower and limited compared with the speeds of a standard local hard drive, 72 RPM drives or 60 megs a second right there. When you do the transition, it doesn't send the file as one big piece. It doesn't send the data as one big piece. It breaks it up into packets so that, so they don't lose one. So if it loses one, it can sort of try and recover and just get that one packet again. Kind of clever, except for what it does is it adds 20% of overhead to every bit of data it's transferring. 20% of overhead, so when the files get to their destination, it can put them back together again. And the last little caveat I'll add is with regards to antivirus software. Antivirus software, just in general, treats files on the network differently than files on your local disk. That just is what it is. There's no way around it. I mean, you can add exceptions for SolidWorks files, and you can add all sorts of things, but antiviruses typically are a little bit more suspicious, often rightly so, of network locations versus your local machine, where the antivirus is locally installed and it has somewhat free reign over the local system to make sure everything is where it wants to be. So all these factors kind of are going to slow your performance. When you're loading across the network, you're going to see slower times. It's easy enough to test. You just got to use pack and go to copy your data set locally and file open from SolidWorks from your local directory. Does it load faster? I will bet you money that it will. And that's where we get to the topic of this presentation, which is PDMWorks. And not just PDMWorks, but PDMWorks Enterprise, PDMWorks Workgroup, or any other PLM products that are out there. PLM products, by design, are designed to allow people to work locally. When you check an assembly out, the first time you check it out, it pulls all the data to your drive. So that takes a little bit of time, about as much time as it takes to load the assembly from the network the one time. But now that data is on your system locally. And as new files are updated, as your neighbor works on a file and your other coworker works on a different file, tomorrow, the day after that, when you open the assembly again, it doesn't pull the whole data set again. It only pulls 1, 2, 3, 4, 10, 15 files, which are new, and it doesn't pull 10,000, 20,000, or even 100 files. So that's the benefit of PDM. And that's my slide for now, and I'm sure I'll talk later. And the one thing I'll leave with that is I mentioned Southbridge and Northbridge. This slide I've been using this slide for a little while now, and when Eric talks, he's going to talk a little bit more about the differences between those and how Southbridge and Northbridge are kind of obsolete now, and they've all been kind of merged and whatnot. But I'll let Eric take that away.
Good stuff, Mark. Appreciate that, especially the little explanation at the end here about the Southbridge and Northbridge. That's probably a term that a lot of us haven't really dealt with in the past, so we'll look forward to learning a little more about that. Quick question for you as well. I'm going to start a quick poll question here as we transition, and Mark, if you can stay active here for a second, I want to ask you a couple more things as well.
Absolutely.
We're going to ask you real quickly if you can tell us what type of operating system you're currently using. This is good stuff for Kevin and Eric to know so they can kind of point their discussion in that direction. If you'd take a minute to answer that. Mark, just a common thing, it's great that you talk about gigabit and gigabyte as well. That was good background. The pack and go process that you talk about, we'll talk about that quite a bit with some of our customers. How does that vary from, say, just copying the files onto your desktop and running that test? What are some of the considerations that users should play on there when they want to do that pack and go process versus just drag some stuff and drop it on their desktop?
Well, when you do drag and drop, you're either copying or moving. But the problem with that is if I take an assembly, okay, we'll call it assembly X, and I have components A, B, C. All right, if I just use a Windows copy to drag and drop that to my local workstation, if I load assembly X again, because I just used Windows copy, it's still going to look for components A, B, and C on the server location, because nested in the assembly is the last loaded location. To save time, we don't just, when you load an assembly, we don't just sort of scan your network or scan your machine broadly. We have a very specific routine of order which we go through to try and find those components. And looking at the last known location is one of the first things in that list. And if they're not there, then it makes some other changes. But so even if you just copy it locally, you're not going to get a true test because it's still going to look to the server location. Pack and go does a little bit what PDM does behind the scenes. It manages your references for you. If you say pack and go and you say copy my entire data set from the server to my local drive, what it does is it goes to the assembly and it says, part A is no longer here. Part A is now here, and you should look for it here when you load it. So it's a way of copying your data set and updating all the references so that they will look to the location where you copy it to, or to a more wildcard type directory if you make a zip file of it and then you extract that zip file later on.
Mm-hmm.
So that's Pack and Go. And with regards to your operating system question, I'd be curious to see what the numbers are for this group here. But SolidWorks as a company, we have performance logging information we have, which I'm going to sidetrack and actually mention here just for a second, if you guys don't mind.
Sure.
Performance logging from the data we get from our users, better than 50% of our user base is now using Windows 7 x64. So that is that.
Well, guess what? We got some numbers in here. There's a few people that haven't voted yet. They're stepping up here. It's getting close to 100%. But right now we've got 53% who are using Windows 7, 39% using XP. No Linux fans out there, or maybe they're fans but just can't work with it. And then we've got a few people on Vista. About 8% of the people are on Vista right now.
All righty. See, so that continues. That shows what we're seeing here. Windows 7 is I'm a big fan of it. You know me, Dennis and Darren and Dennis both know me. I have little nitpicks with Microsoft about it, but overall, I think it's a great operating system. It's better than what we've seen in the past. And the thing I'll throw about performance logging is, I want to throw out to all your users, is that you guys, we really need you guys to turn to, the setting is called Enable Performance Logging, but the setting itself is sort of misleading. How it's misleading is that SolidWorks is always performance logging. Every time you launch SolidWorks, it is taking a check of what video card you're using, what driver, and it's just pulling this information from Windows, which it's readily available. So it doesn't slow your system down. It just grabs this information in an instant. And we're always doing that. It's always happening. And the setting Enable doesn't really enable whether it logs it or not. What you're telling it is, do you want to anonymously and quietly send it using an RSS feed behind the scenes to SolidWorks so we can gather that data? When SolidWorks crashes, when it hangs, when things like that go wrong, and it's captured in the performance log, and it's sent to us, and those logs don't, they're not like the Microsoft error logs where you say, do you want to report this to Microsoft, and it vanishes into a black hole. We get those log files. We have our QA and development teams get those logs, divide them up into different buckets, and they track how many issues happen in certain areas of the code. And then not only do we fix SPRs, but when new projects come out, when 2012 and 2013, we look at a bigger picture and we say, this section of the code, according to performance logging, has some problems. So we're not just going to fix a few bugs in it. We're going to get rid of this entire chunk of code and write brand new code for it. So performance logging, you guys, customers, I can't stress enough, turn it on. It doesn't make SolidWorks run slower. It doesn't slow things down. You're always doing it. We're always recording it anyway. Why not send it to us so that we can make the product better for you guys?
That's great information, Mark. Hey, one more thing on the Pack and Go. If a customer works with all their data in one single folder for a project, say project-based design, and everything is there, are they going to run into any other issues if they just copy that whole folder across versus Pack and Go? Or are there still some of those considerations?
Well, it's still going to look for the network location, even if they're all in the same location. It's still going to look. The only way you would be able to force it to not look at the network location is if you disconnect it from the network drive, or you force SolidWorks to not find the files. If you force SolidWorks to not find the files, then it will look in the local directory where they are. So whenever you're moving files around, you should use Pack and Go. It's the safest way. It maintains references, and the only caveat I would throw out there about Pack and Go is it's a good way to manage your references, but you do need to be careful with Pack and Go, because effectively, and with anything, whether it's Pack and Go or just copying, you are making a copy of the data. You're making there are now two versions of Part A on your network. I mean, at one point they're the same, but if you start working on one of them, it's going to be different from the one that's on the network. And if my buddy starts working on one, and my neighbor works on the other one, and that's when Darren's going to talk more about that when you have more than one person working on the same project and you have more cooks in the kitchen. So
yeah,
that's
we'll
a whole other
that
part
a little bit at the end
Darren will
here.
get into.
Mm-hmm.
But Pack and Go is a great tool. I would recommend anyone who's working over the network now, take 2 seconds, use Pack and Go, copy your data set local, and just get out a little stopwatch, or go, just Google stopwatch, and there's a little JavaScript stopwatch, and just see how long it takes to load lightweight, resolved, and see how long save times take. You're going to see faster performance on your local machine, and that's where PDM is a product which manages that all for you.
Good stuff. Thanks, Mark. We'll look forward to hearing more from you as we move forward here.
Good stuff.
Sharing the results from our polls just so everybody can see how the final numbers came in there. And we'll close that off and move over to Kevin from SafetyNet, who's going to talk to us about that network infrastructure and the network server environments. SafetyNet is a service provider in those areas. You can see some of the products that they represent, and he might want to talk a little bit about his company as he transitions into the topics here that we're going to be getting into next related to the infrastructure environment. Kevin, turn the mic over to you.
Great. Hello, everyone. Thanks for the introduction. Yeah, real quick, as you guys kind of saw from my personal slide, it mirrors really pretty much what we do as a company. We really are an infrastructure-focused company, so you can see our accreditations there. We work with most of the major infrastructure companies in the IT industry. So I'm not going to spend a lot of time there. Why don't we go ahead and start talking a little bit about network infrastructure. So usually we get kind of brought in when there's some kind of performance issue where files aren't saving quickly, or maybe there's really long open times and things like that. And we start really digging into the network and trying to figure out where's this bottleneck, what's causing it. So the typical areas that we've uncovered, it's typically a bottleneck between switches and really at the server. As was previously mentioned, most people are running gigabit networks now, and that is 125 megabytes per second. Typically, real world, we're seeing about 90% of that you can actually use. So it's a pretty decent amount of speed, but the bottleneck really is that connection from the switch to the server. All the workstations each get a dedicated channel for that 125 megabytes a second. But if there's 10 of them pulling at once from one server, then you've got a bottleneck there. So that's a pretty typical thing. When we're looking for these things, one of the most common quick things we'll do is, if anybody's used a tool called MRTG, it's a free tool that can pull and ping information from your network switches and summarize it all into graphs. And you can look at those on a daily basis, weekly basis, monthly basis. But basically it'll let you see the performance spikes at the different switch ports and try to isolate kind of where your problem is. Another typical issue you'll run into with a bigger network is you may run into, let's say you've got 50 workstations and it doesn't all fit on one switch, and 2 switches are implemented. Most switch uplinks today are still 1 gigabit uplinks. So then you're additionally, introducing that 1 gigabit bottleneck where you've got all these people coming across the one connection to get to the server. So one thing we're starting to look at considering is a lot of switches will have 10 gigabit stacking ports, or you can actually get 10 gigabit Ethernet ports you can stack them with. So I've kind of threw a picture on there. I don't think the HP guy will mind that I did this, but HP's got a really nice ProCurve chassis-based system. And since those switch blades that you see in the picture are all plugged into the same backplane, you get really good performance between switch banks. So that can be an option if you've got a bigger environment as well. And kind of the last thing I'll mention on this slide, from a network performance standpoint, that server being a limiting factor, NIC teaming is something that most servers are capable of doing. And what it'll allow you to do is aggregate that connection across more than one NIC port. So you could use 2 or perhaps 4 connections to get you from 1 gigabit to 2 or 4 gigabits. And that can help performance if you're seeing a bottleneck there as well. And one more thing while I've got my mind on it. The last poll we took was on different operating systems. One of the things that was implemented with Windows 7 and Server 2008 was IP version 6. IP version 6 is turned on by default, and I can't tell you how many issues we've seen where the IP6 stack tries to get in front of and fight the IP4 stack. There are no environments that we've actually worked in so far where IP version 6 is a requirement for the business. It's actually doing anything. So what we've done in all those cases is there are some registry settings that you can inject that will globally disable that protocol from the operating system, and we've seen significant performance improvements by just removing that. So that might be something you want to write down and take a look into. Okay, going. Oh, we got a quick poll up right now, so I'll let you.
Yeah, good information, Dad. There. And Kevin, I just turned on another poll just to take a temperature to just see where everybody feels they stand right now today. We got a pretty alert crowd today, I'll have to tell you, because they started filling it out without any prompting. So be on your toes, I guess. We're just about done here, and then I'll turn that off. Give them a couple seconds here yet, and I'll post those results and then let you move on forward here. One more second. It looks like a couple people coming in here yet, and we'll close that. And let me show you those results real quickly. And you can see pretty much everybody in that upper half, so not too bad, I guess, huh?
Not too bad. At least nobody's totally disappointed.
Yeah. And that's always good. Don't want to be too frustrated, right? But you do want to always improve. So let's hide that, and we'll turn it back over to you here for the next section.
So kind of moving on, I mean, typically where we do see the issues is that file open and close. And, you know, if we can resolve the bandwidth issue, then we really start looking at the server and the server's ability to, you know, serve the data. So if we look specifically at server guidelines, you know, again, we look at bottlenecks. And a lot of people think, well, let's put a new server and get one of those big fancy new Xeon processors and put a whole bunch of RAM and stuff in there, and that'll speed it up. And what happens is it really doesn't speed it up. Processing and memory typically are not bottlenecks in file servers. They don't use a lot of those resources. We already discussed kind of NIC bandwidth and how to address that, but you know, really want to focus in at kind of the disk level, and that's kind of what most of the slides that I have talk about is really taking a look at that disk level. From a monitoring and tuning standpoint, you know, we want to know kind of if you have an issue there before we go proposing making any changes. So I would suspect most of you that do any server administration are familiar with Performance Monitor. It's an integrated tool. It's part of Windows Server 2003, 2008, I believe 2000 as well, if anybody still has that. But you can basically load that tool up, and you can look at physical disk performance counters. There's several of them that you might want to look at. I included a link down there at the bottom to a TechNet blog that was really good as far as looking at server performance metrics and things like that. So you might want to take that down and take a look at that. But the key indicator that we usually zero on first to see, you know, real quick snapshot if there's a problem is the average disk queue length. You'll be able to tell really quickly. If you have an average over 1, that almost always indicates that you've got a disk bottleneck. A good number, an average number, is typically 0.1 to 0.2, and that indicates that the system's really able to keep up most of the time with the requests that are coming in. You will want to watch that over time, as you can imagine. First thing, 8 in the morning, everybody's opening up their drawing files and things like that. You're going to expect some bottlenecks and things like that. So you want to kind of check it throughout the day as people are saving and doing updates and things like that to see if it continues to be a problem. Some other kind of monitoring or tuning advice, rather, is you really want to make sure that you're keeping your disks defragmented. As you're pulling up a file, ideally on the disk, it's written in one continuous string on the platter so that when the platter's spinning and you're doing a read, it does one quick read. What happens is the disks kind of get filled up as they'll start breaking that file up into chunks as they find free space on the disk. And so instead of doing one continuous read, you might end up doing 5 or 10 or 20, and it really will have a significant reduction in performance of the overall system. And then kind of leading into that, too, is you want to keep an eye on your disk free space. Usually what happens is when the disks start to get filled up beyond 80%, you run out of that free space on the disk, so it'll start reusing little bits and pieces that are open, and it'll automatically start fragmenting itself. So it kind of exacerbates the problem. It makes it kind of grow quicker than it normally would. So yeah, if you're kind of looking at those things.
Real quick, Kevin, those tips probably, those last couple about defragmenting and free disk space probably apply at the workstation level as well?
They would apply at the workstation as well. And there are some tools, DiskKeeper's been around for a really long time, that you can put on to automatically schedule those. And with the new Server 2008, there's some ways that you can script defrags to make them run automatically. But if you're looking at these things and you are kind of still seeing, and you've got some disk problems, then we'll want to take a look at upgrading the disk system. And I've got some additional slides and kind of some considerations you want to look at there.
Okay.
Kevin, Mark here from SolidWorks. I want to throw a quick question in here that if you're running a server system with like a NetApp rack where you have 10 drives in one of the RAID configurations, I'm not sure, I don't remember what RAID number it is, where you have 10 drives and you can pull a few drives out and it will seamlessly rebuild the data from the missing drives. How does defragmentation or fragmentation affect that type of system? Is that an issue on one of those large drives, or is that not an issue anymore when you're dealing
That's still an
with
issue.
that level of redundancy?
Right. Those systems basically do all the logical RAID partitioning. So as far as the operating system on the server is concerned, it's presented with a logical file storage group, which it applies its own file system onto, in which case same rules apply. As it gets filled up, it'll start to fragment it out and things like that. So.
Cool. Thanks, Kevin. Didn't mean to interrupt you there.
Okay, so I kind of want to talk about different disk systems. We deal with this all the time. Obviously, there's multiple choices out there now, and they're really not all created equal. So as you're going to design a server, you've got kind of these three choices. You've got SAS, SATA, and SSD. And I'm going to talk quickly about these different versions. SATA, as most people know, is a technology that was originally introduced into the desktop and workstation space and later adapted for server use. And the reason that people put it into server use is because from a cost standpoint, it's really attractive. It's really pretty expensive storage. And then also I can get, really big drives. I can get 2 terabyte drives and things like that, so I can make these huge storage pools. From a performance standpoint, though, they're really not the greatest selection. They spin at 7,200 RPMs, and most of them all run at 3 gigabits a second versus some of the other speeds that you see on the other ones. And then just from a mechanical standpoint and the technology that's written in, they do a really poor job of doing multiple read and write jobs simultaneously. So if we really look at the other alternative, which is SAS, these drives are really the replacement for SCSI, which a lot of people probably still have in their environment. SCSI was really designed to do a much better job on the multiple read-write jobs. And then from a revolution standpoint, they'll spin at 10,000 or 15,000 RPMs, and they run the channel runs at 6 gigabits. So significant differences between those two platforms. And then also, I think we already discussed a little bit on solid-state drives. We're seeing more and more of that in the workstation space. Still not seeing a lot of that in the server space because those drives are a little bit different, and they do offer great performance. But from a cost standpoint, they tend to be about 20 times more expensive than even SAS, just because you're looking at typically $1,000 maybe for a 50 gig drive that will work in a server versus maybe $600 for a 600 gig drive. So there's a big difference between the two of those. And then I'm going to talk a little bit about some RAID guidelines. So we're going to kind of pull all this together at the end here, but there's lots of different kinds of RAIDs, and a lot of people are kind of mystified by all these. So I just put together a real quick list on the common ones that are commonly used in network environments, and I'm going to talk quickly about some of those. So RAID 0, hopefully nobody's using that, but you can create those with 2 or more drives. The reason people will go to it is because from a performance and disk capacity standpoint, it doesn't get any better. They're really fast because you can, the disk is basically spread out, and you can read and write to all those disks at the same time. But I got in bold there. It's a great way to lose your job. There's no redundancy in it at all. If you lose a drive, you lose everything. So you'll pretty much never see those in any kind of network environment just because of the risk that goes along with it. We get into RAID 1s. RAID 1s are basically 2 drives mirrored to each other. You lose half the capacity simply because of mirroring. The performance is actually pretty good. From a read standpoint, you can actually read a group of data from both disks at the same time. From a write standpoint, you have to write the data twice, so it doesn't do as well on writes. Typically, you'll see those for operating systems, really not for data storage and things like that. We get into RAID 5, which is very common. You see a lot of RAID 5 out there. You need 3 drives to create an array. You lose the total number of drives minus 1 for capacity. It's safe. Performance is really pretty good. Then we get into a RAID 10, which if you look at RAID 0 and RAID 1, you put them together, you've got RAID 10. So 4 more drives in even numbers, you lose half the capacity. It's very safe, though. I mentioned RAID 0 isn't, but RAID 1 is basically a complete mirror of RAID 0. And you get excellent performance. And then something that's been more new lately is you get into these RAID 50 and RAID 60s, where you've got kind of uneven number of drives. But a RAID 50 is basically 2 RAID 5s striped together. So you get some performance changes. You lose a little more capacity. It's actually a little bit safer. You can survive more drive loss. So I'll get into my next slide, and we can talk a little bit more about what you want to use. So these are some relative performance numbers. We do a lot with sand technology, and Ecologic's a partner of ours. They've got a sizing tool that we can use. The numbers don't actually mean anything in terms of I/O per second or megabytes or gigabytes per second. They're just kind of relative numbers. But what I did is I basically put a quick table together to show you the difference between these different drive types and the different RAID types and what it means in performance. So we kind of started a SATA drive on a RAID 5, which typically we see in a lot of environments. You'll see it's kind of got a relative performance of 58. As we go across the line there, if we get into RAID 10, we almost double the performance. If we get into RAID 50, it's more or less the same. We go down to SATA, or SAS rather, the 10K. You can notice even under RAID 5, even though it's only spinning 50% faster, we get 2.5 times the speed out of it, which holds true as we go across to RAID 10. And then we get into the 15K, and again, you see a significant performance increase. So depending on how we design the RAID disks that we select, we can have a huge difference in performance. If we'd have gone with, let's say, 10 SATA drives running at 7.2K and a RAID 5, where we went with SAS 15K, and we get 5 times more performance out of that other configuration, so which can make a considerable difference in your file open and write speeds.
While you're bringing that up, I'm going to put a poll out here real quick just to see if people are getting good performance right now from their drives. Seems like an appropriate time to ask this.
And the last thing I want to basically comment on is that more spindles equals more speed. So the more hard drives you can put in there, the RAID systems will read more and write more than one drive at a time, and you will get increased performance.
Yeah, I think that was the last slide that we had for you as well, Kevin. So if you wanted to elaborate on anything else while we're taking the poll, feel free to add it in here while folks are completing this. We're almost done with it here. Close that down in just a second here and post the results again.
Oh, I think that's all I've got, and I'm going to be staying on the rest of the presentation, so if there are any direct questions or things that come up related to that, I'll chime in.
So kind of like the general performance, everyone's kind of maybe middle of the road, so maybe there's some room for improvement and some considerations there that you want to take into account from the presentation today that Kevin shared. Hide that so that we can move on here. Kevin, I want to thank you again for presenting this. And I'm going to turn the stage now over to Eric Piper from HP, who's going to be talking about a little bit of an overview on technology that hits each of your workstations. And probably this is a little more relevant to a lot of our attendees today who actually have a station on their desk that are using SolidWorks. Eric's going to talk about the CPU and your graphic processor, and then he's going to go through a quick rundown of maybe a good, better, best scenario for workstations that some of his clients consider when they're looking at for CAD systems, and he'll be interjecting some monitoring and tuning advice in that as well. And we're going to get Mark back in again to talk a little bit about video card performance, and maybe he'll have a few things that he can interject along the way that pertain uniquely to SolidWorks. So with that, turn it on over to Eric. Eric, welcome aboard.
Good morning, everyone. Can you hear me fine?
I can hear you well.
Yep, we're good.
Okay. I want to do a quick time check here. Are we still on schedule, or?
Yep, I think if we keep it to 10 minutes at the most, we should be pretty good here.
I can do that.
Okay.
Well, good morning, everyone. As Mark and Kevin have mentioned, that there's an infrastructure that's in place for delivering the performance of your data and your application. And I'm going to talk about the part of it that sits right in front of you, the workstation.
Do you want me to put the slide up there real quick for a poll on technology update time? So you have a little insight into what folks are doing here?
Sure, that'd be great.
We'll do that while you start talking here.
Okay, so what I wanted to talk about briefly is some of the changes that have happened over the past couple of years in the technology area. I'm very encouraged to see that many of you are already on Windows 7, and hopefully you're using newer hardware, because there's been some really amazing advances that have happened over the last 24 months. Most of that has to do with some of the new technology that's come out of Intel. Specifically, about 2 years ago, Intel released some technology they called codenamed Nehalem. And there's a slide, the next slide we'll get to, we'll talk a little more in detail, but it's basically a new set of technology that they're using where they have integrated the memory closer to the CPU. So what that means is you get a much larger boost in performance. You have much faster access to the memory, so overall application performance goes up. And so we've seen, when that first change happened about 2 years ago, we saw at the same price point about a 25% performance boost. Now, just recently, and actually as we're speaking right now, this spring, Intel is transitioning to their second generation integrated memory architecture, codenamed Sandy Bridge. That's bringing at least a 20% boost over the previous Nehalem technology. So if you're using 3-year-old computer systems, moving to something today, you're going to easily get a 50% processor boost from that technology. So that's something you might want to take a look at. The other big part of the performance that you see as users is in the graphics. And in those same 24 months, both NVIDIA and ATI, now branded AMD, they've had at least 2, close to 3 generations of product that's been out since then. And in general, when you move from, in the graphics realm, when you move from one generation to the next, you're getting a 50 to sometimes 100% performance boost at the same price point. Basically, the message on this this slide is that the new technology is substantially faster than the products that you might have that are there 3 or more years old. There's also a small commercial at the bottom on the AMD. They've got a new set of graphics cards out there, the V38, 48, and 5800. The 4800 specifically is a very, very good price performance card. So this talks a little bit more about,
yeah.
I'm sorry?
I was just saying, Eric, while you're transitioning over there, just to recalculate the poll, about 56% of the people are updating every 3 years, it looks like.
Now that's fantastic. That keeps you in the sweet spot of the latest technology, and it really helps with you know, performance and manageability, and that's really good. So I just wanted to mention a little bit. Mark talked a little bit about South Bridge, North Bridge, and we're going to discuss that briefly here. So if you look at the left-hand side, so if you have a system that's 2 years old or older, this is the architecture that you have. So you basically have the processor, and it connects through a front-side bus. There's not a line there, but you go to the middle box to all the other parts of the graphics, all the other parts of the system. And then it goes from that chip, which is called the North Bridge, to the bottom box, the South Bridge, which is where you're connected to the disks. So everything has to go up and down through that, and all the I/O between the CPU and the rest of the system has to go through that front side bus. So it's between the top box and the second box. So sometimes that front side bus can be a bottleneck. So what Intel did with their Nehalem architecture, you'll see that in the i3, i5, i7 processors and the newer Xeon processors. They moved the memory controller, the MC, and the graphics into an on-die with the CPU. And they directly connect the memory to that. So that means that the access to memory is much, much faster, And in fact, the graphics, certainly with the new Sandy Bridge, the graphics and the memory they're also sharing onboard cache. So overall, that means it's a large performance boost. So then from that, you would have a connection. Here again, we're not showing a line there, but down to the I/O area, much like the South Bridge on the other part, but it's a lot more of a compact architecture and much faster. So what I wanted to show was a couple of examples of the current workstation technology, kind of a good, better, best, and wanted to talk about these briefly. There's some guidelines in the next slide that we'll go through in terms of sort of rules of thumb. But in general, what you're looking for is a processor that's really fast, the fastest you can afford. At least 4 gigabytes of memory. More memory is better, obviously, and a reasonably fast hard drive. And I'll talk to that a little bit. This will be a little different consideration for a workstation hard drive and disk subsystem than you would have on the server that Kevin talked about. And then you want a fairly fast modern graphics card. Now there's a couple of things I wanted to point out here as we look at these examples. I've got a star in the middle, and that's probably a really good sweet spot. And it's got this V4800 graphics from ATI. It's the FirePro. That's really a great card, and it's got a very fast dual-core processor. Now if we look at the best column, you'll notice that the processor speed is a little slower, but it's got a much larger cache, and it also has a lot of memory. It has 12 gigabytes of memory. And the other thing that happens on that right-hand one is that instead of a dual-channel memory that you see on the two on the left-hand side, it's tri-channel memory. So that's why you have this 12 gigs. So it's actually 6 cards, 6 memory cards in there. So you're getting 3 accesses to memory rather than the 2 of the other one. One of the things that is always a question about when you're running your application and it's not performing the way you want is, why is that? We've talked about some of the challenges you have over the network, but once the model and the model files move to your client, there are bottlenecks, and what are those bottlenecks, and how can we determine whether our hardware is configured properly? So on HP workstations, we have a free tool that we call HP Performance Advisor. The images on the left-hand column there show kind of the menu that you're presented with, so you can take a look at the configuration of your computer. It will notice what sort of application software you have on there, and then you can monitor your performance. Now the areas that you would want to look at that typically are things that are important on your workstation are how much memory that you're using. So this Performance Advisor has a very nice tool that shows you the memory in use by various processes. You can look at, I apologize, that center image is not very good, but it's showing different aspects of the system from CPU to disk usage, so you can get some idea of what areas of the system are saturated. And the bottom little picture is a really neat tool that's within the Performance Advisor. It gives you an idea of how much you're utilizing the graphics card. So in this case, we can see that we've got plenty of onboard memory. We're only using 66%, but the graphics processor is red there, and it's using 93% of that. So if you're seeing a lot of performance issues, that would tell you that upgrading the graphics card may be a good idea. And then finally, the right-hand column is part of the tool that helps you optimize the system environment. So in the center there, it's showing that the graphics driver that you have installed is not the best one and is not the certified one for the application. So in this case, for SolidWorks, it's not. So it's recommending that you would upgrade to a new graphics driver that should help with bugs and also performance. So this is my last slide, and these are some rules of thumb that as you're looking to upgrade possibly to new workstations, these are some things that you might want to consider. They're in roughly priority order. So as you're determining how you're going to spend your money, I would start at the top and work your way to the bottom. So CPU, get the fastest one you can afford. Typically, a dual core is fine. Sometimes quad core, but you really want the fastest clock rate. You really want enough memory. 4 gig is the real practical minimum, and you can go up from there as your budget allows. Graphics are also a really key part. I'm sorry, is there a question?
Yeah, we have a question related to CPUs, and one of the attendees would like to know about any comment you might have of using an i5 versus an i7 or the Xenon processor.
Excellent question. I was anticipating that. There are architectural differences between those three. So in general, we'll start at the Xeon. Generally, Xeon has 3 memory channels versus the i5 and i7 only have 2. So you're going to get a little bit, so for large models and large work, the Xeon should in general perform better as long as you configure the system properly. You want your memory in 3s, in 3 card increments rather than 2. The other difference between the i5 and the i7 is the i7 tends to have a little bit more onboard cache, and then they also have this technology they call Turbo Boost. And what that is when this happens at the chip level. So if you're running something that is just using one of the processors and the other cores are not in use, it will turn down the other cores and basically overclock the cores that are in use. So the i7 has a higher ability to overclock higher.
Okay.
Does that answer the question?
We'll see. We'll see if there's a follow-up to that.
Okay. And I know I'm running tight on time, so let me just finish quickly. Graphics, I would recommend a professional graphics, so the NVIDIA Quadro or the ATI FirePro. These are going to be certified by your software vendors. I find the mid-range graphics is typically the best sweet spot. You don't really need to overpay for the high-end graphics. It's usually got features that you really can't use. From a disk standpoint, I recommend trying to, if you're going to spend money, spend it on memory and move to a 7200 RPM drive. You really want to make sure you're working out of memory for the best performance. And I'm really encouraged that everyone is moving to Windows 7. That's really a good way to get some free performance out of your system that you're not getting if you're using XP or Vista.
One quick question to go back to disks as well. We have a number of customers that use RAID configurations. Do you have an opinion on, I know RAID 0 didn't necessarily work so well in a server environment, but could that be kind of an entry-level consideration for a user on their workstation?
Well, RAID 0 is going to give you the best performance, and as long as you can live with the downside that if, so now you're striping your disks basically, and so if you lose one of the drives, then you've lost everything. As long as you're doing good backups and you can handle that sort of error condition, then that would definitely give you great performance at a really reasonable price.
So if you're using PDM to keep your data on that network and only locally working with it, you probably cover that risk factor then pretty well.
Yes.
Moving on, I think we're going to have Mark talking to us real quick on video cards. We're running short on time here.
Yeah, I'm just going to talk quickly because folks, we get this question very frequently, and I just wanted to answer for you guys. People frequently ask, how does a graphics card get onto our certified list? Why do we certify certain cards for one version with certain operating systems and other ones? And then also, how do we select the graphics drivers? Well, I can tell you, we don't just pick them out of the air. We certify graphics cards based on what the manufacturer or the system manufacturer requests us to. Example, HP, they have a workstation line of machines. So they ask us to certify their workstation machines with the configurations which they sell. And the driver which we certify for them is the one which they have found from their internal testing is the most stable as an operating system level as an out-of-the-box configuration, and then we run our tests on it, and then it either passes or fails. So there may be newer drivers out there. I have 3 examples here. I happen to use Dell because I was doing another presentation at the time. Example: the Dell M6500 comes with the Quadro 2800M and Windows 7 or XP64. As a result, we're going to certify that for Windows 7 and XP. Okay, we're going to certify it for that configuration because that's the way it's sold. Now, if we move on to something like the older Dell M65, which I still have on my desk, have forever, it had a Quadro 350M. It was only sold with XP. Okay, so we only certified that machine for XP. Now, I happen to have Windows 7 on it, and it's fine. I'm using a driver. I just happen to find I'm actually using a Vista driver I found for it, and it works just fine. But we don't certify that because it's not. Dell doesn't sell it. Was never sold in that configuration, so we don't certify it. The same thing goes for the Dell T7400 workstation, which has been replaced for the T75, and in some ways it has the same hard drive controller, same hard drives and whatnot. But it's the, new generation does have some upgrades and whatnot in there. They both have the same. You could buy them with the same graphics cards. But the 7400 was only sold for Vista and XP, not Windows 7, so we don't certify that machine for Windows 7 because the system manufacturer never certified it or qualified it for Windows 7, so SolidWorks isn't going to either. But that gives you an idea of why we certify some machines for some things and not for others. The thing which is not on this slide, which I was just thinking about, since better than 50% of you are using Windows 7, you all need to be using an Aero theme, okay, and not using like a Windows Basic theme. You need to be using an Aero theme, and the reason is because SolidWorks, when we take a step back, what is it? It's one giant OpenGL application. Okay, it uses OpenGL technology, and when you go to a basic theme from an OpenGL from an Aero theme, what Windows 7 does at the operating system level to increase your overall CPU performance, this is for people who do not have dedicated graphics cards, it turns down, way down, the OpenGL hardware acceleration. It's the same thing as if you remember from Windows XP way back when on the Troubleshoot tab, you could lower hardware acceleration, set it from full to none or somewhere in between until, if you were having stability problems, it was a testing thing. It wasn't meant to be used all the time. Well, Windows 7, if you go to a basic theme, it will disable, shut off a lot of 3D acceleration settings, especially for OpenGL. So if you're using a basic theme, you are probably going to see repaint problems. You're going to see maybe hangs. You're going to see graphics window locking up, freezing up on you. And so you need to be using an Aero theme. And that's just a little thing I wanted to throw out there because we've been seeing some of that as more and more people go to Windows 7, and they think, oh, because Windows says, well, if you go to a basic theme, it's going to be faster. Well, that might be true for web browsing, but it's not faster for an OpenGL intensive application like SolidWorks, where you've spent the money on a workstation has certified hardware and has really high-end hardware compared with the machine that your grandma, your sister, your brother, or one of your family members uses to check their Yahoo mail. Actually, I don't know if anyone ever still actually uses Yahoo mail still. Anyone? Still, there should be a poll. Do people still use Yahoo Mail? But anyway, that's what I have.
We didn't add that one.
We
didn't add that poll. No, I didn't have time for that one. Sorry.
Moving on, though. That's what I have for video cards. If there are specific video card questions, either Eric or I can answer them for you folks. Just type them in the box, and if we don't have time, we'll try and get back to you.
Yep, definitely. Still running tight on that time, so our next subject is going to be talking about some of those common symptoms you might see that relate to working with data over the network, and Darren Grosser is going to introduce some of those subjects. There's 3 topics we're going to talk on. Fortunately, it's Darren talking, so he's going to go at the speed of light here, I'm sure.
Yeah, thanks.
And we'll try and get you out of here in time for lunch as fast as possible. Darren?
Hey, thanks, Dennis. I've gotten a lot out of today's presentation already, and I was part of building it, so I hope the audience is hanging on and getting some great information. So let's just quickly try and wrap this up with one solution that's more of a software-based solution instead of hardware. And we're going to talk a little bit about data management and how network performance, managing those external references with a complex tool like SolidWorks functions, as well as when multiple people have their hands in the same data with the collaboration. We don't really see data management so much as one of those things that's going to mask these types of performance issues. Although, if there wasn't any hardware changes made and your corporate network is slow or performance isn't acceptable, EPDM or any other PDM really for that matter will actually help that quite a bit by bringing the files locally. So all of the I/O issues and the different bounces that data takes when you're working from a network folder versus local can definitely be addressed by adding this software solution. So the way that we can go ahead and speed up some of these issues with the corporate network is really helping with the collaboration, because collaboration requires that network storage of files. You have to be working in a shared folder for the most part when using just a standard Windows environment. And the biggest issue with that, obviously, is that when you're working from that location, performance can be very slow. Really don't know what resource is being used because obviously there's a lot of jumps it takes from the server to the hardware the user's using, back to the server, and so on. So we've got a lot of things that are actually being used to try and manage these files. And then reliability. This is a huge one that people kind of understate, because people will attribute instability with an application that might be crashing or just simply not hanging on as long as it needs to. But it really has to do with a lot of the collisions and other traffic situations that are taking place on that network, since the files reside there instead of locally. So the reliability over a network, you know, we've even had a situation one time where there's terrible instability within an engineering company, and it was all attributed to a bad printer driver on a salesperson's computer on the other side of the building. And when they would send a print job, the collisions would take place, and the event logs showed that SolidWorks users using data off the network were actually getting kicked off because of that. So it really is amazing when you're working on a network, not only just hardware issues, but other contributing software issues that are there. When we're talking about a tool like Enterprise Data Management, it addresses these things in a variety of ways that have already been discussed. But here's a little performance monitor shown off of just Windows Task Manager about how opening a given assembly across the network from a shared folder looks. And it's all relative here. We're just really showing the distance, how many spikes we get, and really the connection and the performance that are shown. If we move forward on that a little bit, by using a tool like EPDM, it doesn't open the file from the network. It quickly copies it locally, and then your local resources take over. Your fast RAM, your good bus speed, your nice video card, all of that takes hold, and the files are sitting in your local cache. So we eliminate those constant network hits for every save and rebuild and other calculating operation that people typically do. And the comparisons are pretty obvious here. If we're trying to open the file locally or from a shared folder, really, time is money. So if you're going to wait for the network, that's what you're going to see on the left with the red stripe. And if you're going to have it brought locally using data management, we can really improve that throughput and get users working quicker, faster, and a lot more stable. Now, moving on to the external references part. Any SolidWorks user on the line knows that assemblies and drawings depend on the part files to be opened fully. So we have a lot of very intelligent referencing happening from one file to another. Well, when that happens, one file changes, affects other files, especially when top-down assembly design is employed. So it's really difficult on surface level to just look at a series of files in a folder and know that by changing one, what is that going to do to the rest of the files that you have? You'll open an assembly. Maybe somebody went into Windows Explorer and moved a file, so you'll eventually get the unable to locate file window. You know, copying models for similar or different design, we see a lot of this as a band-aid for trying to do what we call Windows data management. In other words, somebody will copy an entire folder, rename the folder to today's date, Rev2, maybe a customer name in there. And the fact is that you're copying the files so that they can be edited. And that's great, because the files that need to change will get changed. But in essence, we're getting redundancy upon redundancy with all of the other files that have been copied over that actually didn't change and may never change, simply because they could be standard components. So we're bringing the files locally, but only really retaining the changes when it comes to how the data management tools will version or revision control those files. So when files are brought down, you know, you can intentionally move it local with something like a pack and go, but it's too many times that the unintentional move or the unintentional rename causes cascading issues or problems. So working locally, saving it to the network, you know, that's wonderful, but every network that I see has folder upon folder that's nested within, and trying to take a folder, a set of folders, and bring them locally, and then be able to make sure that you put the changed files back into all their folders where they need to be, it's a daunting and a darn near impossible task to make sure that that happens properly. So things that happen. I'm sure everybody has come into a situation at one point or another where you've opened an assembly. And lo and behold, somebody went into Windows Explorer and simply put, maybe renamed a folder, renamed a file, moved a file, deleted files. And all of a sudden you have these daunting, unable to locate things where you simply have to manually browse to try and find the files if they still exist there. Got to hope that they do. So what happens is one of your colleagues, they did a folder cleanup. It's looking in his C: desktop because that's where they were last saved. And now we've got another set of things where collaborative use will actually turn out to bite you. So we want to avoid those kind of things, and data management definitely takes care of that. Whenever we're managing files like this, ever opened up a file and had it explode on you like this? Well, this can happen. One edit to a feature, because of the way feature history is built and parent-child relationships are kept, one change might make a really bad change to the rest of the features and cause rebuild errors. Well, this can happen for a variety of reasons, but to recover it, you might spend the time trying to fix the features, or you might just decide to go back to a previous version of that file that was a good version. Without data management, it's a trip down to the IT office and hope that they've got a backup within the last few days. Maybe they can find it on the tape backup, maybe not. Well, if we're using data management, it's not a big deal. We can always just go ahead and simply get the latest version from the vault. The vault contains all of that additional cache, and when it's brought locally, then those files are saved locally on your computer. So we have a great safety net built in by using the data management tool in order to maintain that network infrastructure, saving it in the folders on the network where it needs to be for backup purposes, but allowing you to bring it locally and deal with all the versions as they change, instead of a Windows environment where when you hit save, it's overwritten everything previous to that, and you've got no safety net except for a cryptic or difficult to get to tape backup. A previous slide that I also had there that was relative to some of those collaborative issues that we're looking at right here is you've got a lot of colleagues designing parts in an assembly. Most companies will have several people working on several subsets of a large assembly. It's typically not just one designer's job for the entire subassembly itself. And we need to allow you to have confidence that you've got the right stuff, the right data that's up to date and is the latest and greatest versions. Because as those copies take place, you really have no audit trail whatsoever of what part is in what version, is in what state, or is the one that you were working on recently. So there's a lot of methods within the data management tools that takes care of this. So we're using applications that are grabbing files from the same source, and that's the only way to make sure that the data is current for everybody. When it's copied local, everybody's on their own. So we want to make sure that that's not the issue. Here what we have is actually a SolidWorks assembly, and within SolidWorks using EPDM, we can tell everything about this model just by the way it looks in the EPDM tab. I can tell what files have changed based on the little pencil that's there. The up green arrow indicates that this file is now a newer version than the one that's in the vault. If I had some things that were out of date or a colleague of mine actually changed a file that's in the assembly I'm working on, I'd actually see an indication over there on the side that a new version exists for one of these files, and I could update directly to that version right away, get to the latest and greatest versions of those files. What we also do here, and I'm just going to open up my Windows Explorer for a second, is directly within EPDM, it's built right into Windows Explorer, which to me is one of the beauties. It's the simplicity of it. And it maintains these references in a way that's comfortable for a user, but in a Windows environment strictly is a real big gotcha when it comes to file renames. What we're actually looking at right now is a large miter box assembly. It just happens to be a miter box saw. And looking at the bill of materials of this, we can see a list of everything that's accurate and up to date and all the file names that are actually physically shown in here. And at this point, they're all serialized as a SolidWorks dash, 20,000, 30,000, 40,000, depending on part, assembly, or drawing. Well, it's built directly into Windows Explorer. So if a user does a simple thing that they would do every day, like a simple slow double click on a file to do a rename, I'm going to name this file in a very obvious but very different way. When I click back on the assembly that contains that file, I'm not worried about it, because as I scroll down this bill of materials again, what you'll see right away is that that file rename was actually taken into account. Paths were updated, references were changed, and everything is completely seamless. If I was just using Windows for this, when I try to open that assembly, it would eventually say it could not find the file. Would you like to browse? So, simple example, but it's one of those things where a data management tool that's purpose-built for increasing performance and stability and allowing for this collaboration can really raise the bar quite a bit in your quality.
Good stuff there, and I'd say that the three things you covered here in a short period of time are probably the bulk of what we hear and talk to customers and get in issues coming into our help desk on, wouldn't you say?
Yeah, I would definitely agree with that. We spend a great deal of time trying to deal with lost references and getting the assemblies packaged back up properly after they've been broken through a variety of these methods, or in improper use of a variety of these methods, I should say.
Definitely so. For Eric specifically, with the HP Advisor that you covered, is that something, somebody would like to know if that's something that's available for download for their generic system, maybe not necessarily HP environment?
Unfortunately, the HP Performance Advisor will only work on HP workstations.
And Dennis, just to add to that, Dennis, we at DASI, the engineers, are using EliteBooks now currently, which is an HP desk. I would call it a workstation laptop, but I think this tool is on my laptop, although I haven't used it. Am I correct in that assumption?
Yes, it should be. It comes pre-installed.
Okay.
Although I do have to say there are some Windows tools that are built in that can give you some of that information. You know, so Task Manager, the Performance tabs, Network tabs, and the Performance Monitor part of Windows will give you much of that information.
Great. Well, that's
not quite as user-friendly to use, but it is available.
So that'll be good.
One,
yep.
Mark here from SolidWorks for video card monitoring specifically. There's a tool out there called GPU-Z. If you just Google GPU-Z, you get it's a little app you can download that will show you actual temperature. You know, how much RAM is being used, video RAM you're using at any given time, what the clock's video RAM is running currently at, what the temperature of your video card is, and all sorts of little stuff. So that's kind of a cool, fun little one to have. So you open up a bunch of SolidWorks document windows and you see things kind of get a little funky on you. You know, try using something like either the HP tool or GPU-Z to check the memory usage. And if you get, you know, 80%, 90% of memory usage, you can start seeing funny things, and it might be time to upgrade your hardware.
A lot of good tips that we've been putting out here today. I think I'm going to ask our panel to provide a little summary of some of the things they mentioned that we can post on the blog site to provide a central place that anybody who's interested in getting that information can go to. Launching two more quick polls as we wrap things up, and then we're going to answer some questions while you're answering these as well. There's a few of them that came through here. A little summary here on if you could increase your performance. We've been asking a lot about how you feel about that right now, and we've touched a lot on the hardware side. Aaron touched on the software side on things that can improve it. Looks like 10 to 50% is kind of where the majority of people fall into where they'd like to shoot for improvements there. And I'm going to leave this up for a quick second so that if you'd like to get in touch with any of us directly, you can jot that information down. We've got our blog site posted at the bottom of the slide. If you haven't bookmarked that already or you haven't tied into it as an RSS feed, we'd encourage you to do that so you can stay up to date on the latest postings that we're having there. Like I mentioned earlier, we're looking at getting information out there at least on a weekly basis. And I think as I look at it right now, there's probably about 3 articles that are dealing specifically with this performance issue. And we'll be getting more back into kind of the comfort zone, if you will, for a lot of our users, talking about tips and tricks and different settings related directly inside of SolidWorks moving forward as well. Look for a lot of that coming out there also. And so with that information, I'd just like to put up real quick our last slide and just to see your thoughts on how we met with our expectation today or your expectations. Let us know what you thought of our presentation today. We appreciate your feedback. It helps us stay on track and improve continuously and make sure that we're bringing topics that are of interest to you. So we appreciate your time again. And if there are any further questions, don't hesitate to get in touch with any of us as well. Darren, anything for you to wrap up?
I definitely appreciate our panelists. I got a lot of information from SafetyNet, from Hewlett-Packard, and always from Market SolidWorks. So I appreciate your collaboration with this, guys. Thank you.
As the users, if you find this interesting and you'd like to see more guest speakers, let us know. We're definitely open to that as well. And kudos to all the guys with the information that you presented. Really got a lot out of it myself and appreciate all of your time today.